Well, first of all, let me say this. If you were not in here yesterday due to taking the ACT or any other reason, we did a short activity. It's nothing you need to make up. I was not going to start the next chapter with a majority of the class gone, so we are starting chapter 4 today. Chapter 4 is on quadratic equations and functions. So some of this chapter is review. So I need everybody's attention up here. Phones should be away right now. Class is beginning. Ladies, Jenna. Some of this chapter will be review. Some of this chapter was not covered in Algebra 1. So like a lot of things in Algebra 2, we start with reviewing what you may have learned in Algebra 1, and then we build on that. So we're doing the same thing with quadratic functions and equations. The beginning part of this is pointing out a lot of vocabulary that you need to know, some formulas you'll need to know. Ultimately today, if it looks familiar, it's from Algebra 1. So it's reviewing how to graph a quadratic function. I'm just going to point out some things that you need to be careful of, and then how to find or interpret the maximum or minimum value of a quadratic function or equation. So first of all, I want you to be able to see an equation and recognize that it's quadratic if you can't already. Same with linear, because later on in the year when we have equations that we're solving, if I ask you what type of equation this is, it's quadratic. How do you solve a quadratic equation? So just recognizing that is very important. So a quadratic function or equation, in those functions and equations, the greatest exponent on the variable is 2. So x squared, or if x isn't your variable, whatever it is, the highest exponent is 2. So these functions will have 3 terms typically. It is possible that 1 or 2 of the terms are missing, and that would mean those terms are like zeros, but these functions will have a quadratic term, so that is the term that has the x squared, or again, whatever your variable is, squared. And then they will have a linear term, so that is the term that just has x, or x to the first power. And then they will also have a constant term, and this is the term that doesn't have a variable, so this would just be a number. And it does give the general quadratic function, f of x, which is just y, equals ax squared plus bx plus c. So a will always be in front of the x squared, that's your quadratic term. B is always in front of the x, that's your linear term. C is always your constant term. And it does specify a cannot equal 0, and that's because if the a value is 0, you would not have an x squared, and therefore the function wouldn't be quadratic. So the only value in this function that can't be 0 is a. But reviewing some things that you may already know from Algebra 1 about quadratic functions. The graph is called a parabola. We've talked about parabolas already this year a little bit. So here's where we have a whole chapter to really talk about them. And then the rest here is going to go through key characteristics on the graph of a parabola. These are the characteristics we use to graph them ourselves. So all parabolas have an axis of symmetry, and this is a line through the graph of a parabola that divides the graph into 2 congruent halves. So each side of the parabola will be a reflection of the other side. So on this graph that's given at the right, the axis of symmetry, we typically draw in as a dashed vertical line. It's not part of the parabola, it's just used to help us graph the parabola. So that's the axis of symmetry. You can see we could reflect the left side over to the right or the right side over to the left, but along that line it is symmetrical on either side. And then the axis of symmetry will intersect a parabola at only one point, and that's the vertex of the parabola. So on this parabola that's given to us, the vertex is this point A, and it gives the coordinates 3, -3. For every parabola, the vertex is either the lowest point, like in this case, our parabola is opening up, the vertex is the lowest, or if the parabola opens down, The vertex would be the highest point. And then this next part is talking about the symmetrical nature of the graph. So it says, notice points B and C on the parabola. These are both, or rather the x-coordinates of those points are both 4 units away from the x-coordinate of the vertex. So if you look at the x-coordinate of your vertex, that's 3. If I go 3 to the right, I'm at the x-coordinates, or 4 to the right, sorry, I'm at the x-coordinate 7. 4 to the left, I'm at the x-coordinate -1. And then notice those 2 points, because they're the same distance away from the vertex, the y values or the y coordinates are the same. So that's how we're going to use the axis of symmetry to help us graph a parabola, or you might remember, like I said, doing that in Algebra 1. So we'll talk more about that. And then this box at the bottom gives some formulas that you'll want to know as you're graphing parabolas yourself. So for any quadratic function, the y-intercept will always be the value of c that's in the equation. So if you remember finding y-intercepts with linear functions, this is where you replaced all of the x's with 0, because any coordinate on the y-axis, the x-coordinate will be 0. And if x is 0, that's what they're showing here. For every quadratic function, the y-coordinate is going to be c. So the ordered pair 0, c will always be the y-intercept. And then you have an equation to find the axis of symmetry. So this equation you would need to know, bless you, x is equal to negative, or the opposite of b over 2a. And then because the axis of symmetry intersects the vertex, or intersects the parabola at the vertex, the x-coordinate of the vertex is also negative b over 2a. So that's because the axis of symmetry intersects it. I usually refer to the axis of symmetry. If you hear me say AOS or write AOS, that's what I'm referring to. And you can write that as well, just for shorthand. So ultimately, for the first example, we're going to be using this information as we graph. The first things I find when I graph, I find the AOS, I then find the vertex, I then find the y-intercept, and then I find other points so that I can graph my parabola. So if we look at example 1, this one, I didn't include this for the second one. It's not included on your assignment, anything like that, but I did break it down into really the 3 steps I follow. I just explained to you the 3 things I usually find first. So we have our function, f of x equals x squared plus 4x minus 3, and it says state the domain and range. So when you're graphing, I usually find the axis of symmetry first. So that was the formula on the front. The x equals the opposite of b over 2a. And the a and the b come from the function you're given. So remember that your function is in the form f of x equals ax squared plus bx plus c. So a is always in front of your x squared, b is always in front of your x, c is your constant term. That's where this a and b are coming from. So in our function, what is the a value? What value would be in front of the x squared? 1. And then b, is 4, thank you. C is negative 3. Okay, so then in our formula, opposite of b over 2a, we're going to have the opposite of 4, so negative 4 over 2 times 1. So that's negative 4 divided by 2, so that's negative 2. Make sure, if I just ask you for the AOS, or axis of symmetry, it is the equation of a line. So you need to write x equals negative 2. The number itself is not the axis of symmetry, the equation is. So I will typically draw this in because I use it to graph the parabola. So through the x value -2, I'm going to draw a dashed vertical line. Do you have to draw the AOS in? No, but it is helpful when you're graphing. After I find the AOS, I find the vertex. And the vertex is an ordered pair. So because, again, the AOS goes through the vertex, the x-coordinate of the vertex is the x value your line goes through, so it's -2. And then if I know the x value for the function, how would I find the y value? Because before I can plot my point, I need the y-coordinate. Yep, plug it in. The equation is given right at the beginning. This is the function we're graphing, f of x. So I replace the x with -2 or the x's with -2 and evaluate it. So I would have -2 squared plus 4 times -2 minus 3. And here's where you just need to be careful following order of operations, evaluating this. If you're typing it in a calculator, make sure you're typing it in correctly. What I mean by that is if I just type in, I think I've showed you this before, if I just type in -2 squared, the calculator says it's -4. What is -2 squared? +4. Your calculator is saying -4 because this is taking 2 squared and then taking the opposite of it. If you want -2 squared, either just mentally know that it's positive, or when you type it in, you need to put the -2 in parentheses and then square it. So don't just say, well, my calculator said it was negative, so it must be negative. You have to be smarter than the calculator. So -2 squared is +4, plus 4 times -2 is -8, and then we have -3. So 4 plus -8, that's -4, minus 3 is -7. So -2, -7. And then I'm going to plot, usually once I find something, I plot it right away. So I can plot -2, -7. And then for the y-intercept, so this is always your c value, -3. So it's the ordered pair 0, -3, or if you just said -3, that's okay. But make sure that goes on the y-axis. It's the point at the y value, -3. Okay, so any questions so far on those 3 things that we found? Okay, so then for step 2, now whether or not you actually make a table, that's up to you. The only reason I would check your table when I'm grading this is if I can't quite tell where your points are at on your graph. But actually filling in all of the table, if the table confuses you, you don't have to make it. However, I am requiring that when you graph a parabola, you graph at least 5 points, because that's going to give you a better shape than just having 3 points. So right now we only have 2. So I'm going to put the 2 points we do have in a table. The vertex is going to be the middle point, if you want to think of it that way, of the parabola. So I typically will put that in the middle of the table if you want to put a V by it to make sure you know that that's the vertex. And then I also have the ordered pair 0, -3. And depending on how you organize your table, just put that wherever. I can, right away, without plugging anything in, I can find another point on this parabola using the axis of symmetry. So notice where the y-intercept is. I can go horizontally to the left. I can go over a distance of 2 to reach the axis of symmetry. That means now if I go 2 to the other direction, that point is also on my parabola. That would be the coordinates -4, -3. And if you are filling in the table, you can notice from the vertex, both of those x values are a distance of 2 away from the vertex, and that was the 2 I was referring to on the graph. And their y coordinates are the same. So you're using that axis of symmetry to just plot other points rather than having to substitute in a ton of x values. And then I do still need 2 other points. So what I do from here is I just pick an x value that I don't already have on my graph. So what's an x value that I could substitute into my function? I could do -1. I could also do +1. I could do +5 if I wanted to. So you don't have to do a value that's in between the values you already have. You can do any value that you're not already using. So I'm going to substitute -1 into my function. So I have -1 squared plus 4 times -1 minus 3. -1 squared is +1 plus 4 times -1 is -4 minus 3. So 1 and -4 is -3, minus 3 is -6. And then I can plot that point, -1, -6. And now I don't have to plug in another x value. I can use symmetry by finding that one point. I can use symmetry to reflect it over to get another point. So what other point would also be on this graph? Yep. If I go over 1, I'm at the AOS. Go 1 again, I'm at -3, -6. Okay, there are my 5 points. Once you have them, draw a smooth curve between the points. Parabolas are U-shaped, they're not V's, so make sure it's not pointed. I know sometimes if they're really, really narrow, it's hard to make it rounded, but do your best. And that would be the graph. So that's the last step, is actually graph the curve. Okay, and then I'm also having you find the domain and range. So the domain for every quadratic function is the same. Domain, remember, is the x values. X can be anything. So on the graph, you'll notice we did plug in some x values, but this curve is not only continuing up forever, it's continuing out, meaning it's going to cover every single x value on the graph. So the domain is all real numbers. You can put the all real number symbol or actually write all real numbers. That doesn't matter. Always, yep. For every quadratic, it'll be all real numbers. The range, though, is different for everyone, and it depends on the graph. Range is the y values. So notice for this parabola, because it's opening up, the lowest y value is the vertex, and that's the y value -7. All of the other y values are higher than that. So the range is y values that are greater than or equal to -7. So your range will always be an inequality. The value that's here will always be the y value of the vertex, because that will always be your highest or your lowest point. Questions on that? Okay, so I would like you now in your groups or individually, whatever you want to do, graph example 2. One thing I want to point out, for this function in example 2, what is the a value? -1. Make sure when you substitute x values in that you are following order of operations. Exponents come before multiplication. So I'll give you a minute to get started on this. I'll walk around, answer questions. But graph example 2. I've given them in the past. I give them, but I don't say what they're for. So you still have to know, like if you see x equals -b over 2a, you have to know that's the axis of symmetry. I'll give it to you, but you still have to know when to use it.
Well, it's because like the negative 2 and the 1, they're not; those aren't going to have the same y value because they're a different. Like negative 2 is only half a unit away from this, whereas 1 is 2 and a half units away. So that's why you're able to see it because these aren't symmetric. So if you like pick which one you want to plug in, but like if you're doing negative 2, then you would go with negative 1. If you're doing 1, it would go with negative 4. It's all about how far. So that's why sometimes round is helpful because then you can see how far it is. I do it.
All right. I know some of you are still finishing up. So my first way around, I just wanted to make sure you could all get the right vertex. So please, well, this is me. I know I'm saying please, but you want to make sure you're watching out for this so you're not getting it wrong on a quiz or test or even your assignment as you practice, because we'll be graphing these quite a bit. But I had this set up. This is the work to find the y value of the vertex, because you were all able to get the negative 1.5. Make sure when you plug it in that you are writing it like this. So you have to do with order of operations the exponent first and then multiply by negative 1. Or if you're just typing it in your calculator, type it in this way. You're not canceling out the negative or these two negatives here. That doesn't work. So are there any questions on this example? I know some of you are still finishing up. Any questions I didn't get to answer as I walked around? And check that you have the right, domain's always all real numbers, but check that you have the right range. Y is less than or equal to 6.25. Okay, so if you still have questions with any time remaining today, make sure you let me know. The second part of this is finding kind of the same things, but we're not graphing. So it's interpreting what we've just found. So I already kind of mentioned this, that the vertex is either the lowest or the highest point. So the y-coordinate of the vertex of a quadratic function is the maximum or minimum value of the function. And that's because when you have a vertex, the y value really shows the height on the graph. So if it's the lowest point, the y value is the minimum value. If it's the highest point, the y value is the maximum value. So this table here really shows you just from an equation how to determine if you have a maximum or a minimum. So this is without graphing it. So if, and you could look back at your two examples we just went through as well, if your a value is greater than 0, so your a value is positive, this means your parabola is going to open up, and therefore your vertex will be the lowest point, so it will have a minimum. So that would be like example 1. The a value is positive 1, the parabola opened up, our vertex was our lowest point, so that y value was the minimum. If your a value is negative, like in example 2, the a value was -1, that parabola opened down, and therefore the vertex was the highest point, so it has a maximum value. And then this kind of shows graphically what that's explaining, and then just so you understand, the max or the min is the y-coordinates of the vertex. So it's not the entire coordinates or the entire ordered pair for the vertex, but just the y-coordinate, because that gives the height. So this is what these problems will look like, or what you would be expected to be able to answer, again, without actually graphing the function. So you're given a function. It says determine whether the function has a maximum or minimum value, and then in part B, state what that value is, and then in part C, state the domain and range. And again, this is all without graphing. So to determine whether a function has a maximum or minimum, all you need to know is what the a value is. What's the a value of this function in example 3? 4. 4 is a positive number. So since the a value is positive, I then know the parabola is going to open up, and therefore the vertex is the lowest point, meaning we have a minimum. Okay, so the answer to this is minimum value. I'm going to write out my reasoning for how I got there, so you looking back at this understand why it's a minimum, or if you were asked to explain it, you would know how to explain it. So my thought process was, since a is positive, the graph of, and I'm just going to put f of x, referring to the function I'm given, the graph of f of x opens up meaning the function has a minimum value. So what's the a value? Does that mean the graph opens up or down? And then does that mean your vertex is the highest or lowest, meaning you have a max or min? That's really all you need to know is a, to know if it's a max or min. But you have to understand how to get to that reasoning. Are there questions on that? If based on how this is asked, if you would just have to say maximum or minimum, but if I asked you to explain, I'd be looking for something like that. I mean, word for word, it doesn't have to say exactly that, but I have to see that you understand why it's a max or a min, and it's based on the a value. So then in part B, it says now state that max or min. So how you find the max or min is the same. In this case, we just know from part A, it's a minimum value, not a maximum. But stating the max or min, this is basically asking you to find the y value of the vertex. So you have to know the max or the min is the y value of the vertex, and then find it. So what I want you to think about now is how to find this. So think back to examples 1 and 2 when we graphed the function, we had to find the vertex. What did we need in order to find the y value of the vertex? The axis of symmetry. Because that's also your x value of your vertex. And that was our x equals opposite of b over 2a. So what is our b value in our function? So if we have the opposite of b, that's the opposite of -24, so that's +24 over 2 times a is 4, and that would be 8. So 24 divided by 8 is 3, and it's positive. So yes, that's where the axis of symmetry is. That's also the x value of the vertex. And if we know the x value, we can substitute it into the function to find the y value. So the y value is going to be, if I substitute it in, 4 times 3 squared minus 24 times 3 plus 11. So here again, if you're just typing it in your calculator, that's fine. Just make sure you're typing it in correctly. Otherwise, make sure you're following order of operations. So I have to do 3 squared first, not multiplying 4 and 3 first. So this is 4 times, let's see, 3 squared is 9. And then minus, I can multiply 24 and 3, that's 72, plus 11. And then 4 times 9 is 36. So 36 minus 72 plus 11. That'd be negative 36 plus 11, so negative 25. So negative 25, that is just the answer. I'm just going to write this out, the minimum value, just to again specify in this problem that we have a minimum, not a maximum, is negative 25. So usually with this type of question, students want to give the entire ordered pair for the vertex as their answer. The vertex is not the minimum or maximum value. It's only the y value of the vertex. So I want to see that you understand that. Are there questions on part B? Okay, and then part C, you are now stating the domain and range of the function, again, without graphing it. What is the domain? All real numbers. What about the range? Anyone have an idea of the range? Without y is greater than or equal to, not 4, negative 25. So again, the negative 25 was the minimum value. Therefore, all of your y values must be greater than or equal to that number. Yes. Yep. But just like if you looked back at examples 1 and 2, this value in your range is always from the vertex. Okay?